Hello friends, good evening. This is Manoj, the founder of Acknowledge India YouTube channel. Our main motto is education for all. So friends, in the geography series, today we are going to discuss about oceanic currents. In this session, we are going to cover the basic part of oceanic currents and the factors affecting the oceanic currents. And in the next session, we are going to discuss ocean by ocean, like Atlantic, Pacific and Indian Ocean. Okay friends, let's move on to the topic. So friends, now we are going to discuss about oceanic currents. First of all, we'll see the definition part. An oceanic current is a seasonal directed movement of seawater generated by forces acting upon this main flow, such as breaking waves, wind, the Coriolis effect, temperature and salinity differences, while tides are caused by gravitational pull from the sun and the moon. So friends, now we'll see the oceanic current direction. In general, currents in the northern hemisphere travel in clockwise direction in a gale, while currents in the southern hemisphere travel in the anti-clock direction. So the only exemption is the current direction in Indian Ocean, which changes seasonally. So friends, now we are going to discuss about the main factors of the oceanic currents. So the first one is salinity. Salinity is a measure of how much salt is dissolved in water. The average salinity of seawater for all Earth's oceans is about 35 grams of dissolved salts per kilogram of seawater. This is shown as 35 parts per thousand. The Red Sea and the Mediterranean Sea contain some of the saltiest water on the Earth. In some areas, these bodies of water show salinity measures as high as 40 parts per thousand. Global salinity patterns are linked to rainfall and evaporation. Salinity affects seawater density, which in turn govern oceanic circulation and climate. The higher salinity of the Atlantic sustains the oceanic deep overturning circulation. Salinity variations are driven by precipitation, evaporation, runoff, and ice freezing and melting. So the next factor is temperature. In general, currents in the western part of every continent are cold. Currents coming from the polar region are generally cold. Currents near to the equator are generally warm. There is a counter equatorial current which moves from west to east, that is warm current. The west wind drift moves from west to east, that is cold current. Let's discuss about the impacts of Coriolis force. First of all, let's see the definition of Coriolis force. An effect whereby a mass movement in a rotation system experiences a force acting perpendicular to the direction of motion and to the axis of the rotation. Coriolis force is a deflection of movement objects when they are viewed in a rotation reference frame. In a reference frame with clockwise rotation, the deflection is to the left of the motion of the object. In one with counterclock rotation, the deflection is to the right. Important observations about Coriolis force. The currents flowing from equator towards the North Pole and the North Pole towards the equator are deflected to their right, while the currents flowing north to south and south to north in the southern hemisphere are deflected towards their left. So friends, that's all for today. In the next session, we are going to explain about Atlantic oceanic currents. If you do like the video, please subscribe and spread a word with your friends. Thank you very much. Namaste.